Hello, good day everyone. So let me introduce myself first. I am Roger C. Kalamba, taking up Bachelor of Science in Industrial Technology, major in Electrical Technology 3. For today, I will be discussing to you one of the chemical elements of the lanthanide series, which is the gadolinium element. Now, are you ready? Okay, let's begin. But before we proceed, I want to ask you, are you familiar with this element? Have you ever heard this element before? Or is it your first time to hear about this element? Maybe some of you are already know, but maybe some of you were not. But don't you worry, guys. We will explore this element together. Is it interesting, right? Yeah, but please listen carefully, because I will be giving some questions at the end of this presentation. And please bear in mind that there will be some questions at the end that cannot be seen in the PowerPoint presentation, but from my verbal discussion. So, please listen carefully and try to internalize my discussion. So, are you now ready? Are you sure? Okay. Now let's begin in 3, 2, 1. Gadolinium. Gadolinium is a chemical element with a symbol capital G small letter d and an atomic number of 64. It is a silvery white metallic element and a member of the lanthanide series of the chemical elements. It is located at period 6, block F, as shown in the given periodic table. It is one of the 15 elements found in the lanthanide series. These elements are characterized by their softness, distinctive silver color, and their reactivity when exposed to moist air. Gadolinium has a relative atomic mass of 157.25 and a density of 7.90 gram per centimeter squared or cube. It has a melting point of 1313 degrees Celsius and a boiling point of 3273 degrees Celsius. It also has an electron configuration of xenon 4f to the power of 7, 5d to the power of 1, and 6s to the power of 2. It has 5 stable isotopes and has 2 radioisotopes with over 158 GD as the key gadolinium isotope due to its 24.84% natural abundance. It is in solid form at a room temperature of 20 degrees Celsius. Its estimated crystal abundance is 6.2 milligrams per kilogram, while its oceanic abundance is about 7 by 10 to the power of negative 7 milligrams per liter. Gadolinium is considered one of the rare earth metals. Compounds containing gadolinium may be found in such technologies such as microwave ovens, televisions, nuclear propulsion systems, magnetic resonance imaging or MRI, and positron emission tomography or PET. In nature, gadolinium is found not as the free element but in various minerals such as monazite and basnazite. It occurs in only trace amounts in the mineral gadolinite. Both gadolinium and gadolinite were named after the Finnish chemist and geologist Johann Gadolin. Today, gadolinium is isolated by techniques such as an ion exchange and solvent extraction, or by the reduction of its anhydrous fluoride with metallic calcium. So, as you can see on the presentation, this is the characteristic of the gadolinium. So, pronunciation, it is pronounced as gadolinium. Appearance, silvery white, and its standard atomic weight 157.25 and plus 0.03. Gadolinium in the periodic table. So again, its atomic number is 64 and it belongs to group in A with period 6 and black F black. Electron configuration of xenon 4F to the power of 7, 5D to the power of 1, and 6S to the power of 2, with electrons per shell 2, 8, 18, 25, 9, and 2. So here are the physical properties of the element gadolinium. So phase at STP solid, melting point at 1585 Kelvin or 1312 degrees Celsius, and in Fahrenheit it is 2394 degrees Fahrenheit. Its boiling point 3273 Kelvin or equivalent to 3000 degrees Celsius and 5432 degrees Fahrenheit. Its density 7.90 grams per centimeter cube, and when it's liquid 7.4 grams centimeter per cube. And then the heat of fusion, and then heat of vaporization, and then its moral heat capacity, as you can see on the slide. So let's go on to the other slide. So we can see here the atomic properties. Its oxidation states 0 plus 0 or positive 1, and then positive 2 or positive 3, and then its or electronegativity, Pauling scale 1.20. Ionization energies, first is 593.4 kg mol, second is 1000 170 kg mol per mol, and then third is 1990 kg per mol. Its atomic radius empirical 180 pm, and its covalent radius is 196 plus 6 pm. And the below you can see the spectral lines of gadolinium. Let's go on to the other slide, and then here we can see the other properties of gadolinium. Its natural occurrence, primordial crystal structure, hexagonal close pack, or its CP, speed of sound 2680 meter per seconds or at 20 degrees Celsius, thin rod, and then thermal expansion Apolli 9.4, and then thermal conductivity 10.6 watts or W, and then electrical resistivity poly 1.300 1.310, and then its magnetic ordering ferromagnetic paramagnetic transition at 293 point key, 0.4 k, and then its molar magnetic plus 755,000, and then 0 by 10 negative 6 to the power of negative 6 centimeter cube per mol. And then Young's modulus, Shear's modulus, bulk modulus, Poisson ratio, Vickers hardness, and then the CA number, CAS number, which is 7,440 or 7440-54-2. So let's proceed to the next slide. So we will now tackling about the history of gadolinium. Gadolinium was discovered by the Swiss chemist Jean-Charles Galessard de Marignac in 1880 at Geneva, Sweden. It was initially thought to be the new element didymium, but Marignac suspected that it was a mixture of elements rather than a new element. Marc de la Fontaine and Paul Emile Lecoq de Boisbaudran proved Marignac's suspicions when they discovered, using spectroscopy, that the element didymium did not match its source. In 1879, the element samarium was isolated from didymium, further proving that the latter is not an element. Marignac first discovered gadolinium oxide from the mineral samarskite when he observed an unknown pattern of spectral lines. Pure gadolinium was independently isolated by Paul-Émile Lecoq de Bois-Baudran in 1886. It was Bois-Baudran who named the element gadolinium after a mineral called gadolinite, one of the minerals where gadolinium is found. The mineral gadolinite was named in the honor of the Finnish scientist Jan Gadolin. Notable characteristics: gadolinium is an inner transition metal or lanthanide that lies in period 6 of the periodic table between europium and terbium. It is malleable and ductile. Unlike other rare earth metal elements, gadolinium is relatively stable in dry air. However, it tarnishes quickly in moist air and forms a loosely adhering oxide that spalls off and exposes more surface to oxidation. Gadolinium reacts slowly with water and is soluble in dilute acid. At room temperature, gadolinium crystallizes to produce its alpha form, which has hexagonal close-packed structure. When heated to 1508 Kelvin, it transforms into its beta form, which has a body-centered cubic structure. Gadolinium has the highest thermal neutron capture cross-section of any known element, about 49,000 barns, but it also has a fast burnout rate, limiting its usefulness as a material for nuclear control rods. And gadolinium becomes superconductive below a critical temperature at 1.083 Kelvin. It is strongly magnetic at room temperature and exhibits ferromagnetic properties below room temperature. Gadolinium demonstrates a magnetocaloric effect whereby its temperature increases when it enters a magnetic field and decreases when it leaves the magnetic field. The effect is considerably stronger for the gadolinium alloy or JD5, silicon 2, and GE2 or Si2 or parentheses Si2, GE2 close parentheses. Next, its usage. Gadolinium has useful properties in alloys. As little as 1%, gadolinium can improve the workability of iron and chromium alloys and their resistance to high temperatures and oxidation. It is also used in alloys for making magnets, electronic components, and data storage disks. Its compounds are useful in magnetic resonance imaging or the MRI, particularly in diagnosing cancerous tumors. Gadolinium is excellent at absorbing neutrons and so is used in core of nuclear reactors. So, the end. So, okay. Nasabtan na ba ako ang report? I hope na sabtan na to ninyo. Now, before ko maghatag sa questions, I would like to leave a quote or a message from Carl Jung, a chemist. He said that the meeting of two personalities is like the contact of chemical substances. If there is any reaction, both are transformed. So, I think that would be all, or I think that would be the end of my report. And I hope that you learned something and able to get new ideas. So don't forget to answer the review questions in the next slide. God bless and good luck. So I think that would be all. Thank you so much, everyone, for listening. Have a good day ahead, and God bless us all. Thank you so much.